There is a moment every survival story eventually reaches, whether in a desert, on a battlefield, or drifting at sea. It is not when food runs out. It is not when shelter fails. It is when water becomes the problem. It's not the lack of it, but the presence of it in the wrong form. Contaminated, stagnant, quietly lethal. History has shown again and again that more lives are lost to unsafe water than to weapons or weather. And yet long before modern filtration systems and chemical treatments, entire civilizations found a way to solve this problem using nothing more than metal and observation. What makes this remarkable is not just that they succeeded, but that they did so without microscopes, without chemistry as we understand it, and without any shared global knowledge. Different cultures, separated by oceans and centuries, arrived at the same solution independently. Because when history repeats itself across continents, it is no longer coincidence. It is evidence. This is not a theory or a trend. It is a survival method, grounded in real use, rediscovered by modern science, and validated in some of the most extreme environments humanity has ever entered. By the end of this, you will understand not only how it works, but how to apply it in a real-world survival scenario using materials that are accessible almost anywhere. The earliest recorded use of metal for purification traces back to ancient Egypt, where healers used copper vessels to treat wounds and store water. This was not ritual. It was observation refined through repetition. Those treated with water stored in copper survived infections at a noticeably higher rate. That pattern became practice. Centuries later in classical Greece, the same principle emerged under entirely different conditions. Greek sailors faced a brutal reality. Water stored in wooden barrels spoiled quickly, turning foul and dangerous within days. Crews fell sick not because of storms or enemies, but because their water betrayed them. Yet when stored in copper containers, the same water lasted significantly longer. It stayed drinkable, even under intense heat. That difference determined whether voyages succeeded or failed. The Romans expanded on this understanding. Their infrastructure incorporated copper into water delivery systems, and their military carried copper vessels as standard equipment. They did not know about bacteria, but they knew outcomes. And outcomes were enough. What makes this more compelling is that the same discovery occurred independently in the Americas. The Aztecs, with no connection to Mediterranean civilizations, used copper-treated water for healing and purification. In India, the practice of storing water in copper vessels has continued uninterrupted for thousands of years. This is not cultural overlap. It is parallel discovery driven by the same natural law. When 5 different civilizations arrive at the same conclusion without contact, it tells you something fundamental is at work. For most of human history, metal-based purification was common knowledge. Copper and brass vessels were everyday tools. Then the industrial age changed priorities. Cost replaced longevity as the driving factor. Plastic became dominant because it was cheap and easy to produce. Chemical treatments like chlorine allowed water to be processed at scale. The shift was not about effectiveness. It was about efficiency and economics. The old methods were pushed aside not because they stopped working, but because they did not fit the new system of mass production. Then, in the late 20th century, something unexpected happened. A routine experiment led to an accidental rediscovery. A researcher working with treated water noticed that when a brass object made of copper and zinc came into contact with chlorinated water, the chlorine rapidly disappeared. No added chemicals, no external power, just contact between metals and water. That observation led to years of study and eventually to a patented filtration method known as KDF. What had once been ancient intuition was now measurable, repeatable, and explainable. When copper and zinc are placed together in water, they create a small electrical reaction known as a galvanic cell. This is not theoretical. It is the same principle that powers a battery. Zinc naturally releases electrons, while copper accepts them. When they are connected and submerged, electrons begin to flow. This flow of electrons triggers several critical reactions at once. Chlorine, commonly used in treated water, is chemically altered and neutralized. It becomes harmless chloride, removing both toxicity and taste. Heavy metals like lead and mercury are pulled out of the water and bonded onto the metal surface through electrochemical attraction. At the same time, the environment becomes hostile to microorganisms. Bacteria cannot survive the disruption caused by this reaction. Their internal systems break down, and they are effectively destroyed. This is not filtration in the traditional sense, it is transformation. Instead of trapping contaminants, it changes them or removes them entirely at the molecular level. When engineers at NASA were preparing for space missions in the 1960s, they faced a unique challenge. Water needed to be purified in a closed environment with limited space, minimal power, and zero margin for contamination. Traditional filtration methods were not practical. Their solution was to use metal ionization, specifically silver and copper, to control microbial growth in water systems. The system was compact, efficient, and reliable. It eliminated bacteria without introducing harmful chemicals or requiring constant replacement parts. This was not a nod to ancient history. It was a practical decision based on effectiveness. When the stakes were highest, they turned to the same principle discovered thousands of years earlier. That should tell you everything about its reliability. Modern water filtration is built around replacement cycles. Filters wear out, cartridges need to be replaced.
Audace!
Systems are designed to create ongoing consumption. This is not inherently wrong, but it does shape what becomes mainstream. Metal-based purification, especially copper and zinc systems, does not fit that model well. The materials last a long time. They do not require frequent replacement. They do not generate recurring revenue. As a result, while this technology exists and is used in some systems, it is rarely the centerpiece. Instead, it is often included as a secondary component behind more profitable filtration stages. This is not about suppression, it's about incentives. Understanding that distinction allows you to make better decisions without falling into speculation. Applying this in a real survival scenario starts with understanding its limits. This method is highly effective against bacteria, chlorine, and heavy metals. However, it does not fully address all contaminants. Certain chemical pollutants and resilient parasites require additional steps. The first stage is simple preparation. If water is visibly dirty, it must be strained through cloth to remove debris. This step does not purify, but prevents clogging and improves effectiveness. The second stage is the core process. A piece of copper and a piece of zinc are twisted together tightly. This contact is essential. Without it, the reaction does not occur. The combined metal is placed into the water and left undisturbed for several hours. Time is a critical factor. The longer the exposure, the more complete the reaction. After this stage, the water is significantly safer but not complete. The third stage addresses chemical contaminants. Charcoal, made from natural wood, acts as an absorber. Water passed through crushed charcoal removes many organic compounds and improves taste. The final stage for those who want maximum safety involves fine filtration. Materials like diatomaceous earth can trap microscopic parasites that survive earlier stages. This transforms the system from partial purification into a comprehensive one. When combined, these stages create a multi-layered approach that addresses a wide range of threats using simple materials. Across thousands of years, the people who survived were not necessarily the strongest or the most advanced. They were the ones who paid attention. They noticed patterns. They tested ideas. They kept what worked. Copper and zinc do not care about technology trends or market demand. Their behavior is fixed by nature. When placed together in water, they will always produce the same reaction. That consistency is what makes them valuable. In a world where solutions are often complicated and dependent on systems you cannot control, there is something powerful about understanding a method that relies only on basic materials and fundamental science. It is not about rejecting modern tools. It is about having options when those tools are unavailable. The next time you think about water, do not just think about quantity. Think about quality, and more importantly, think about control. Because the difference between survival and failure is often not what you have, but what you know how to use. If this deep dive into history and practical survival changed how you think about something as simple as water, make sure you subscribe to Intelligent Survival and share this with someone who values real knowledge over noise. There is a lot more buried in history that still has a place in the modern world.